In this video, we are going to go through how do we solve equations with exponentials in them using logarithms and think about what is the most efficient method in order to do this. So we got our first equation here, which is pretty much the most basic one that you can get. Okay, we've got our exponential term 3 to the power of x equal to a numerical value. Okay, in this scenario, you can jump in straight away, try and use your definition of logarithm and the idea that if the exponential has a base of 3, then your logarithm should also have a base of 3. So our power x would be equal to log base 3 and then of 20. And then all we'd do is put that into the calculator, and then that would give us our answer, which is 2.73 to 3 significant figures. Okay, let's look at a slightly more difficult scenario. Right, so we got this one here, where we've got our exponential term over here, and the power is looking a little bit more complicated. But now this time we have an additional term in the equation, which is subtracted off our exponential term. Now this doesn't make it too much more difficult because this term here is a constant, a numerical value. It doesn't involve x. Therefore, the logical thing to do is to get the two constants we have in our equation, the -5 and the 61, together on one side. So I'm going to start by adding 5 to both sides. So I would get 5 to the power of 4x take 1 is equal to 66. Now we're in a position where our exponential is equal to a numerical value. So now we can make use of logarithms. And we're going to be dealing with log base 5 this time because our exponential base is 5. So our power, 4x subtract 1, is going to be equal to log base 5 and then of 66. Like that. Okay, so we've managed to rewrite the equation where our unknown x is now no longer in the power. So now we can just use GCSE skills to rearrange this and make x the subject. So we would add 1 to both sides. So we would get 4x is equal to log base 5 of 66. And then plus 1, make sure you use brackets for your log, just to be clear that the 1 is not inside the log. And then we need to divide by 4 on both sides. So x is going to be equal to log base 5 of 66 plus 1 divided by 4. If the question asks for your answer as an exact value, then we are done. Just leave it there. However, if you put it into the calculator, then usually, unless requested otherwise, 3 significant figures is good to do for sort of smaller values that you get. So I get 0.901 to 3 significant figures. Let's have a look at our next scenario. Okay, this one is distinct from the other two that we've done so far because we now have 2 exponential terms. Our unknown features in both of their powers. Now, we don't have anything else added or subtracted, which is convenient. And importantly, the base of our exponential in both cases is e. Okay, which means this is not as hard as some scenarios we're going to see later on. Because if we have a scenario like this, what we can try and do is try and get e into only one term. Okay, because it's a factor on both sides. So what I need to do is I'm going to divide. Now we got a couple of options. We can either divide by e to the power of 2t to remove it from here, or we could divide by e to the power of 6t to remove it from there. So what I'm going to do is I'm going to go with the smaller power. Okay, I'm going to divide by e to the power of 2t on both sides like this. So let's try to simplify. So on the left-hand side, we would have 5e to the 6t divided by e to the power of 2t. And then on the right-hand side, the e to the power of 2t is cancelled out by the other e to the power of 2t, so we're just left with 12. Now, the left-hand side can be simplified further, which is what you're going to want to do. Because the base numbers are the same, we can use the division law with indices where we subtract the powers. So this is going to become 5, then e, and then we would do 6t subtract 2t to get 40, like this, is equal to 12. So we've managed to successfully rearrange the equation so the exponential is now only in one term. Now our exponential is being multiplied by a numerical value, so I want to remove that before we start trying to use logarithms. So what we're going to do is we're going to divide by 5 on both sides. So I would get e to the power of 40 is equal to 12 over 5. Now we're in position to use logarithms. So our log is going to be base e. Now log base e, we can write that in a different way rather than using the usual log notation. We can use the natural logarithm ln, or you might pronounce it ln. Okay, so our power 40 is going to be equal to ln of 12 over 5. And then to find t, we just need to divide by 4 on both sides. So we would get t is equal to 1/4 of ln 12 over 5. And if you want an exact value, that is your final answer. However, if we were to stick it in the calculator and we can use the button that says natural logarithm, ln on the calculator, we would get 3 significant figures, 0.219. Let's have a look at our next scenario. Okay, so comparing this one to the previous question, we've once again got 2 exponential terms, nothing else added or subtracted on. However, the bases are different. Therefore, it's not going to be convenient to rewrite the equation so there's only one exponential term. So we're going to have to approach this a slightly different way. Okay, it's going to take a bit more time. What we're going to start by doing in this scenario where you have multiple different bases, okay, a good idea is to take logarithms of both sides. Now, in terms of what base you use, it doesn't matter, okay? We just need to take logarithms of both sides. So initially, I'm not even going to write the base, and if the base isn't written, generally we assume it's log base 10, but you can use any base to solve this equation. So what I'm going to write is I'm going to write log, and I'm going to put the entire left-hand side in the log, so 3 to the power of x plus 1. And that's going to be equal to, and I'm going to write log again, and I'm going to put the entire right-hand side within the log, so 4 to the power of x subtract 1, like that. Okay, so that's going to be your first step, and this method would work for some of the previous questions. However, this is the first one where we're going to have to use it. Now, if we look at what we've got, I don't like the fact that x plus 1 is in the power and x subtract 1 is in the power. So what could we potentially do with that? Well, we could use our power rule for logs, okay, where we can move the power to the front of the log, okay, so it's multiplying the log. So I would write x plus 1, our power, and I'm going to write it in brackets because it's multiple terms, otherwise it's not going to be correct. And then I'm going to write log, and then open my log function, and we would have just 3. Because the idea is that power has gone to the front there. Now let's look at the other side of the equation, and we're going to do similar. That power x subtract 1 is going to go to the front, and we'll write it in brackets because it's multiple terms. And then we'd have log of 4 like that. So I've managed to remove the x's from the powers. Now what we need to do is try and get x on its own on one side. To start that process, we're going to expand the brackets, okay, because we've got x plus 1 in the bracket, and the bracket is being multiplied by the single term log 3. So I need to multiply both the x and the 1 by log 3. So let's do that. So let's do x first. So I'd have x and then log 3. And then we've got our plus 1 times log 3. So that's just one lot of log 3. So plus log 3. And then equals 2. And then on the other side of the equation, the bracket is being multiplied by log 4. So let's do the x first. So we'd have x times log 4. And then we've got negative 1 times log 4. So that's going to become negative log 4. Like that. Now our goal is to make x the subject. Currently I see x appearing twice in the equation. Now if you want to make x the subject, you need to get all of the terms involving x to one side. Okay, so let's move it all to the left-hand side. So we've got the x log 3 on this side. I'm going to leave that as it is. Now the x log 4 on the other side, I need to get that to the left-hand side. So I'm going to subtract that over. So we would get x log 3, subtract x log 4, which is what I've moved over during this line of working. Might just circle it here. And then we still got the plus log 3. And then we got equals 2. And the only term that is left for me to write is the negative log 4, which is left on that side, like that. So now we've moved all of the x onto one side. What I need to do is get all of the terms not involving x to the other side. So you can see on the left-hand side, this term here, the log 3, we need to get that to the other side. So I'm going to write out my x terms first. And then we can write our equals. And then we got the negative log 4, which was already on the right-hand side. And we're going to subtract log 3. So that's now on the right-hand side as well. So we successfully got all the terms involving x to one side, all the terms not involving x to the other side. But the problem is on the left-hand side, x still appears twice. So how can I isolate it so it only appears once? Well, x is a common factor, so we can factorize. We can write x, then open brackets, and we'd get log 3 because that's the first term multiplying x. And then for my second term, we'd have the negative, and then it would be log 4, which is what's multiplying x. And then we can close our bracket, and that would be equal to the right-hand side, which I'm not going to change. Right, so now we've got x multiplied by the bracket. So if I want to get x on its own, I need to divide by the bracket. So x is going to be equal to our right-hand side, which I'm just going to write out, which is going to be my numerator. And then our denominator is going to be that bracket that we've divided by from the left-hand side. So log 3 subtract log 4. Now, if the question asks for an exact value, we are done there. However, you can put it into calculator. I believe this question actually said to 3 decimal places. So let's put it in and see what I get. And when you put it in, it doesn't matter which base you use. You just have to be consistent throughout the entire fraction. Okay, you could use log base 123 if you want. And we get 8.638 to 3 decimal places. Right, let's have a look at our next scenario. Okay, so how is this one different to what we've encountered previously? Well, we've now got 2 exponential terms multiplying each other, and it's equal to a numerical value. Now, what you could potentially do, actually, is if you want to get it into a more familiar scenario compared to the previous question, you could actually divide by 3 to the power of x on both sides. So you'd get e to the power of 4x subtract 1 is equal to 5 divided by 3 to the power of x. And then in terms of what you could do with that, well, if you want to get the 3 to the power of x out of the denominator, well, then the power of the 3 would become negative. So it would become 5 times 3 to the power of negative x. Okay, like that. However, I'm not going to actually approach it in this way. I'm going to go for a slightly different way of doing things. So I'm just going to rub out what we've got here. Now, regardless of what method you use, you're going to have to take logs of both sides. And as you can see, actually, we're asked to give our answer in a specific format this time. Right, so we're asked to give it as an exact value, so you shouldn't really need to use the calculator. Now, the interesting thing to note here is the fact that the natural logarithm ln is present. That suggests when you're selecting which base logarithm to use, you can't just use any one on this question. You're going to have to use the natural logarithm because the question is telling you to. If that wasn't there, then you could use any base log, but because the natural logarithm is in the final format, I am going to take the natural logarithm of both sides. So I'd write ln and in brackets, put the entire left-hand side, so e to the 3x and then times e to the power of 4x subtract 1 is equal to natural logarithm of 5. But what I'm going to do next is consider what's going on inside my logarithm on the left-hand side. Now, I can't use the power rule currently because there is no single power for my product there. It's the bits in the product have got different powers. So you've got power of x, power of 4x take 1. Currently, we can't use our power rule, okay, as it is. We can't have multiple powers like that. So what I'm going to do is somehow want to separate the 3 to the power of x and the e to the power of 4x take 1. To do that, we can use our addition law of logarithms in reverse. So if we have log of a plus log of b, well, that would be equal to log of a multiplied by b. Okay, so the current scenario we have is the right-hand side. we have a logarithm of a product. Okay, RA in our case is 3 to the power of x, and RB is the e to the power of 4x subtract 1. And what I can do is separate this into two logarithms with the same base being added together. So I would write ln, and it would be of 3 to the power of x, and a plus, and then it would be ln of e to the power of 4x subtract 1, like that. Okay, and then that is equal to ln 5. Now, in terms of what I could then do next, well, thinking about which logarithm we're using here, we've used the natural logarithm. Okay, the base of that is e. So therefore, the base e will actually just cancel with this e here to leave just 4x subtract 1. Okay, because if you've got something written that says ln of e to the power of 4x take 1, essentially what this calculation is doing is it's asking you, our base e to the power of something is equal to e to the power of 4x subtract 1. Okay, essentially our argument of our logarithm, which came from in here. So the only thing that this power could be here has to be 4x subtract 1. Okay, so therefore, essentially, we can ignore the natural logarithm and the base e, and we're just going to be left with our power 4x subtract 1. Okay, but we can't do similar for the 3 to the power of x, because, of course, the base of the logarithm is not 3. So I am just going to write that in here. And then equals to ln 5. Now we've still got an x in a power over here, so I want to deal with that. So we can use our power rule of our logarithms and bring that x and multiply it by it at the front. So we get x ln 3, and then plus 4x take 1 is equal to ln 5. Now we're in a far more familiar position to the previous question where we've got x appearing twice. So we need to get all those x terms on one side, which I've already got. Now I need to get all the terms not involving x to the other side. Okay, so that would be the -1. So I'm going to add 1 to both sides. So we get x ln 3 plus 4x is equal to ln 5 and then plus 1. Now we need to isolate x on the left-hand side. So x is a common factor, so we're going to factor it out. And in the brackets, we get ln 3 and then plus 4. And that would be equal to ln 5 plus 1. Then the x is being multiplied by the bracket, so we're going to divide by the bracket. So x is going to be equal to our right-hand side, ln 5 plus 1, divided by our bracket, which is ln 3 plus 4. Okay, which is pretty much in the format that the question was asking for us, although in this case, they want our numerical constants, which is the 1 and the 4. That's going to be a and the c. They want it on the left-hand side. Because we've got addition in the numerator and denominator, we can just write it as 1 plus ln 5 divided by 4 plus ln 3, which would be our final answer for x. Let's have a look at our next scenario. Right, so this one, even more complicated in the sense that we've now got 3 exponential terms in our equation. They're all different bases. Okay, so it's not like it's going to be convenient to maybe divide or multiply to get it. So 2 of the exponential terms can be merged into 1. But usefully, there's nothing else added or subtracted on here. Okay, so this should be quite convenient to do by taking logarithms of both sides. In terms of what base you use, it's completely up to you because there's no format specifically specified for our answer in the question. So I'm just going to take log base 10 of both sides, but I'm just going to write log. So we do log of the entire left-hand side. So log, and then in brackets, we would write 5 to the power of 2x times 3 to the power of 4x. And that would be equal to log of the entire right-hand side. So that's going to be 6 to the power of 5x take 3. Now on the left-hand side, we've got a similar position to the previous question in the sense that I've got a product in here. Okay, and the powers of the two things in the product are different. So therefore, we're going to want to split this up into 2 separate logarithms added together before we use the power rule. Okay, so it'll be log of 5 to the power of 2x plus log of 3 to the power of 4x. And then that's going to be equal to our right-hand side, which is log of 6 to the power of 5x take 3, which I don't really need to do anything with. Now what we're going to do next is going to try and get these x's out of the powers using the power rule. So this power of 2x can come to the front. So we'd have 2x log 5. And then this 4x can come to the front. So plus 4x. And then it'll be log 3. And then on the right-hand side, we'd bring the power of 5x subtract 3 to the front. We'd need to write in brackets because it's multiple terms. So we'd have that and then log 6. And then we successfully got all of the x out of the powers. So what I'm going to do next is on the right-hand side, I'm going to expand our bracket. So our left-hand side, I'm not going to change that currently because I'm pretty happy with how that's written. So when I expand the brackets on the right-hand side, we do 5x times the log 6. So we get 5x log 6. And then we would do the negative 3 times log 6. So negative 3 log 6. Like that. Now we've got 3 terms in total that have x in them. Okay, the first term here, the second term here, and the first term on that side. I need to get them all to one side. So it's going to be easiest to leave the left-hand side as it is and subtract this one on the right-hand side over. So we would have 2x log 5 plus 4x log 3. And then subtract 5x log 6. And then that is going to be equal to the only other term not involving x, so the negative 3 log 6. Now on the left-hand side, x appears 3 times. Again, I want to isolate it. It's a common factor. So I do x, open bracket, and then it'll be 2 log 5 plus, then for our next term, it's 4 log 3. Then for our next term, it's negative 5 log 6. And then that is equal to negative 3 log 6. So x is now being multiplied by this very big bracket. So we're going to divide by that bracket. So x is going to be equal to negative 3 log 6. That's the right-hand side up, which is going to be our numerator. And then our denominator is going to be our bracket. So 2 log 5 plus 4 log 3 take 5 log 6, like that. Okay, and that will be your final answer as an exact value. Now, I do just want to think about other ways we could potentially write this. Now, what we can't do is we can't just cross off all the logs. Okay, log on its own holds no value. It has to be a log of a number. Okay, and there's no log of a number which is a common factor throughout. Okay, so we can't do that. Now, things we could potentially do. The numerator is negative, so I could bring that negative to the front of my fraction. So it would be 3 log 6, and in the denominator we'd have the 2 log 5 plus 4 log 3 subtract 5 log 6. Now, other things we can do, potentially we could try and simplify the denominator into a single term. Now, we could use our addition law and our subtraction law of logarithms. However, before we do that, we need to get the number in front of the log, so the 2, the 4, and the 5 to be 1s. Essentially, that 2, that 4, and that 5 need to come into the log as a power. Okay, so that's what I'm going to do next. Our numerator, well, we could potentially also bring the 3 in as a power in the numerator, so we could have log of 6 cubed. And then in my denominator, the 2 comes in as a power, so we have log of 5 squared. Then plus, and then the 4 comes in as a power, so we have log of 3 to the power of 4. And then finally, the 5 can come in as a power, so we'd have log of 6 to the power of 5, like that. Okay, so it's looking a little bit neater, but in my denominator, I can still do a little bit more. So I'm going to write out my numerator again, which I'm not going to change. And then in my denominator, what I can do, because this is a plus, we can multiply the 5 squared and the 3 to the power of 4. So I'd have log, and it would be 5 squared times 3 to the power of 4. And then because this is a subtract for a subtraction, we would divide by what's inside our logarithm. So we're going to divide by 6 to the power of 5 like that. Okay, and then we can shut our logarithm. Okay, and that is another way of potentially writing our answer. Once again, you cannot just cross out the log. Okay, that does not work because log on its own does not hold any value. Okay, it's not a common factor of the numerator and denominator.